The aim of this assignment is for students to become familiar with the scope of civil engineering works and the application of the common principles of measurements for the purpose of producing procurement documentation using the SANS 1200 and SANS 120 through the investigation of student-sourced case studies. Students are encouraged to source relevant, current, or recent projects within the Greater Cape Town metropolitan area and engage with the local consulting and contracting civil engineering firms. We are NHMS quantity surveyors, and the case study used for this assignment is the Sweethomes GAP Housing Project. Initially, the project will be introduced and the scope of work will be presented. Then the different SANS documents will be discussed that create categories C and D, and their relevance will be mentioned. Thereafter, the measuring systems used for the project will be evaluated by comparing the bill of quantities to the SANS documents. Finally, conclusions will be drawn from this evaluation. The case study described in this presentation is for the Department of Transport and Urban Development Authority for the civil engineering works of the Sweethomes GAP Housing Project. The site is located on Jakes Harwell Drive in the suburb of Philippi in Cape Town. The beneficiaries of the housing project consists of those who qualify for low-cost housing and are primarily from Philippi itself and surrounding areas. The civil engineering works on the site comprises of 3 hectares of site clearance and excavation and will be done by Shaw Civils. The purpose of the work is to provide the houses with a sewage line and proper road infrastructure. The scope of the engineer's work regarding the entire site includes geotechnical investigation, which showed the presence of predominantly soft earth. Site clearance for an area of a total of 3 hectares. Earthworks, bulk excavation, specifically excavation for an installation of cable ducting, stormwater drainage, sewer construction, water reticulation, and civil roadworks along Jakes Harwell Drive.
The SANS 12,000 documents detail standardized specifications for civil engineering projects in South Africa. The documents each detail the scope, definitions, material classification, plant requirements, construction method, tolerances, testing, and measurement and payment for each specification in question. The following SANS documents were consulted for this case study. SANS 12,000C covers site clearance. This specification is involved with the removal of vegetation, boulders, and surface obstructions, such as trees or structures. Earthworks for a civil project are detailed in SANS 1200D. This section includes earthworks for general excavations, short trenches, terracing, and landscaping. Certain SANS specifications are too broad in scope to cover all aspects of the work. These subsections are narrower in scope and allow for more detailed measuring and costing. Additional plant may also be required for the subsections. One such subsection is SANS 1200DB, which is used for pipeworks. This specification details all the necessary requirements involved for the preparation of trenches and the reinstatement of services. The final SANS document that was required for this project was SANS 1200DM. This document deals with the specifications for roads and the subgrade involved. The main sections of this document deal with the subgrades in new roads, the reconstruction of existing roads, and gravel roads where the SANS 1200ME, the subgrade document, is not part of the contract document.
Having discussed site clearance and earthworks as they relate to SANS 1000C and D, the ways in which the case study project handled these shall be analyzed and compared to the SANS specifications and any differences identified and explained. We shall begin by analyzing site clearance, which was done in accordance with SANS 1000C. The importance of site clearance lies in that before civil works can begin, obstructions such as vegetation, boulders, and structures need to be removed. Soil investigation is an integral first step of civil works to determine the soil type, among other soil conditions. Site clearance can then commence, and in the given project, items to be removed included topsoil to a maximum depth of 300 millimeters, trees, fences, electricity lines, and stormwater pipes and channels. Subsection 8.2.1 provides the specifications for clear and grub. These specifications require clear and grub to be measured in hectares, meters, or kilometers. The BOQ provided by Shah Civils conforms to these standards by measuring site clearance in hectares as a total of 3 hectares. Because the total area to be excavated is of a substantial quantity, the site clearance work shall be measured under Clause 8.2.1 of the SANS 1000C rather than Clause 8.3.11 of SANS 1000D. The total area to be cleared has been measured as 3 hectares, therefore the project's large scale justifies its placement in SANS 1000C. The specifications of subsection 8.2.2 require the removal of large trees and stumps to be measured in number and to be separated according to various girth categories. The BOQ has separated according to various girth categories and therefore has met the requirements. The taking down of existing fences is discussed in subsection 8.2.5. The case study has measured the length of the fence in meters, however, and this is shown in the BOQ as 700 meters. The SANS 1200C, however, requires that this be measured in kilometers. To be noted is that Clause 8.2.5 requires the engineer to indicate the site of sorting and stacking. In this case study, however, the contractor approves the dumping site for the materials. Clause 8.2.8 covers the demolition and removal of structures and requires them to be measured as a sum. The BOQ has measured the breaking out of existing stormwater concrete pipes in meters under this clause. However, the breaking out of the concrete pipes would rather be measured under Clause 8.2.7 as required by the SANS specifications with the type and diameter of the pipe given. The BOQ also provides a miscellaneous section that includes works which have not been provided for in the specifications for site clearance in SANS 1000C.
SANS 1200D was used in this case study for earthworks. The excavations in the given case study were in preparation for sewage works and road work. The BOQ used by Shah Civils has been provided for and will be referred to in assessing the differences between what was measured and the requirement of the SANS 1200D document. The case study measures earthworks in volume, which is in accordance with the SANS 1200D document. Item A 8.3a of the BOQ stipulated the disposal of the excavated material as required. Item A 8.7 was accordingly measured as an extra over item for intermediate excavation, and item A 8.8 was also measured as an extra over item for hard rock excavation. Item A 8.3, which outlines imported fill in the BOQ, was not done in accordance with SANS 1200D subsection 8.3.4, as it should have been measured as an extra over item, but was not. Both items A 8.5 and A 8.6 were measured as stipulated in subsection 8.3.6 of SANS 1200D. Limited overhaul was measured in volume and has been separated from long overhaul, which was measured in volume per kilometer. No allowance has been made for bulking. A 8.9 to A 8.14 in the BOQ deals with the location of existing services and topsoiling. The costs of detection, exposure, protection, and alterations for location are covered by these items, along with the rate for topsoiling required to cover the cost of excavation from stockpiles. These items have been measured as outlined in the relevant documentation in cubic meters, with the excavations being done by hand in order to locate existing services.
In conclusion, Shah Civils measured their bill of quantities to the most part in accordance with SANS 1200 C and D. Discrepancies do exist due to the civil contractor having their own preferences of measurement and to the scope of individual projects differing. This assignment gave valuable insight into civil engineering projects.